Hi guys, this is O-Level Chemistry, paper 12, June 2019, question 11. Which mass of carbon contains the same number of atoms as 16 grams of sulfur? So for that, we need to find out the number of moles in 16 grams of sulfur. So that would be 16 divided by the AR of sulfur, which is 32. This gives us 0.5 moles. Now, the number of atoms in 0.5 moles in any element or compound would be the same. That means we need to find out the mass of 0.5 moles of carbon. So now, for carbon, we've got the AR as 12. So we need to find out the mass. The formula is N is equal to M upon Mr. Let's rearrange that. Mass equals number of moles into Mr, which would be 0.5 into 12. And in this case, the Mr would be the AR here because it is an element, not a compound. So this would give us a value of 6.0 grams. So this makes option B the correct option for this question. Question 12. 3 dm cube of sulfur dioxide is reacted with 2 dm cube of oxygen. And the equation is given. Assuming the reaction goes to completion and that all gases are at room temperature and pressure, which volume of sulfur dioxide is formed? So according to the molar ratio, we have 2 moles of SO2 producing 2 moles of SO3. So the molar ratio is 2 is to 2, which is the same as the molar ratio 1 is to 1. So the total quantity of SO2 present is converted into SO3. So if we have 3 dm cube of SO2, completely 3 dm cube of it would be converted into SO3. So this makes option B the correct option for this question. Question 13. A sample of magnesium hydroxide is made by adding an excess of aqueous sodium hydroxide to an aqueous solution containing 1.2 grams of magnesium sulfate. The mass of magnesium hydroxide formed is 0.26 grams. What is the percentage yield of magnesium hydroxide? So now we have magnesium sulfate being converted into magnesium hydroxide. So according to the MR of the compound, if we have 120 grams, which is the MR of magnesium sulfate, it would produce 58 grams of magnesium hydroxide, which is the MR of magnesium hydroxide. And the question has asked us that 1.2 grams of magnesium sulfate is being used. So 1.2 grams will produce how much magnesium hydroxide? We will calculate this by dividing 1.2 with 120 and multiplying this value by 58. So we end up with an answer of 0.58 grams. This means that if the process was 100% efficient, we would have obtained 0.58 grams of magnesium hydroxide. However, the question tells us that the mass of magnesium hydroxide that is formed is 0.26 grams. So we have 0.26 grams being produced out of 0.58 grams that was supposed to be produced. And when we multiply this ratio by 100, we get a percentage yield of 44.83%. So this makes option C the correct option for this question. Question 14. When concentrated aqueous sodium chloride is electrolyzed using inert electrodes, which product is formed at the cathode and which product is formed at the anode? So we have concentrated aqueous. When the term concentrated comes, we have production of chlorine at the anode. So at the anode, option A and option C has chlorine, which eliminates option B and D. And at the cathode, we would have production of hydrogen gas. So option A has hydrogen and option C has sodium. So option C gets eliminated. making option A the correct option for this question. Question 15. Which negative ions are present in an aqueous solution of copper sulfate? Now, since this is an aqueous solution of copper sulfate, we have the sulfate ions present in the solution, and because it is aqueous, we have the OH negative ions from water present in the solution. So, A says copper ions and hydrogen ions. This would be true if they mentioned which positive ions are present. So, both of them are positive ions. So, this option becomes incorrect. Copper only, copper is positively charged, copper ions, so incorrect. Sulfate and hydroxide ions, yes. And sulfate ions only, no. Hydroxide ions will also be there. So this makes option C the correct option for this question. Question 16. The diagram shows the energy profile of a chemical reaction. Okay, and the diagram actually shows that this is an endothermic reaction. Okay, which row is correct? The reaction is the reaction that is endothermic is the forward reaction. So A and B says backward reaction, A and B gets eliminated. And the other column says the reaction with the greater activation energy. Okay, so the activation energy is the energy difference between the reactants and the maximum energy change, which is the transition state. So from the reactants to the transition state is the activation energy. So this is the activation energy for the forward reaction. And for the backward reaction, because products would become the reactants, the activation energy would be this energy difference. So this is the activation energy for the backward reaction. It says the reaction with the greater activation energy. So we can see that the reaction with the greater activation energy is the forward reaction. So option says backward reaction. C gets eliminated. Option D says forward reaction. So option D is the correct option for this question. Question 17. The table shows the energy released by the complete combustion of some compounds. Which compound releases the least energy when 1 gram is completely burned? Okay. So the energy given to us in the table is kilojoules per mole. And we need to find out the number of moles of the compound in 1 gram, and we multiply that value by the energy value given in the table to obtain the energy that is given off when 1 gram is burned. And whichever will have the least energy would be the correct answer. So let's do this. For benzene, the MR of benzene is 78. So we will do 1 upon 78 and we would multiply this value by minus 3270 and we end up with a value of minus 41.92 kilojoules. For heptane, we would calculate its MR, which is 100. So we would do 1 over 100 into minus 4800. This would give us a value of minus 48.00 kilojoules. For octane, the MR calculated is equal to 114. So 1 divided by 114 multiplied by minus 5510. This gives us an energy value of negative 48.33 kilojoules. And last, we have propane. The MR of propane is 44. So we will calculate 1 upon 44 and multiply this by the energy value given minus 2200. This gives us an energy value of minus 50 kilojoules. So as we can see, the option with the lowest value of the energy released is negative 41.92, making option A the correct option for this question. Question 18. An experiment is carried out to measure the rate of reaction between magnesium and dilute hydrochloric acid under two different conditions. The mass of magnesium and the number of moles of hydrochloric acid are the same in both experiments. Okay, if the moles and mass are the same, then what is different? Okay, there are two different conditions. Okay, they will give us in the statements. Okay, graph of the results are shown. 1 and 2 produces the same volume of gas, but one produces it more than the second one in a given time. Okay, okay. So experiment 1 is relatively faster than experiment 2, but there is no change in the volume of gas produced because the moles of the acid and the mass of the solid are the same. Okay, which statement could explain the difference between graphs 1 and 2? Graph 1 results are obtained at a higher temperature. Yes, if the temperature would be higher, the rate would be more quicker. Second statement, graph 1 results are obtained by using hydrochloric acid that is more concentrated. Okay, we can use more concentrated acid, but the volume of the acid used would be less. This would keep the moles of acid equal to any other concentration. By increasing the concentration, we can decrease the volume and keep the moles constant. So this is very much possible. 3. Graph 1 results are obtained using smaller pieces of magnesium. Yes, if we increase the exposed surface area, the reaction would be quicker. However, the mass of the magnesium used would remain constant, so the moles of the gas produced would remain the same. So this is also possible. So all three statements are true, and the reaction can be carried out by bringing about the changes given in these statements and keeping the overall moles of magnesium and the acid used constant, and as a result the overall volume of gas produced remains the same in both experiments. So this makes option A the correct option for this question. Question 19. Hydrogen peroxide decomposes slowly at room temperature, and the equation is given. The reaction can be catalyzed by adding manganese 4 oxide. The diagram shows the apparatus that can be used to monitor the rate of this reaction. Okay, we are collecting the gas in the gas syringe. Which statement is correct when a catalyst is added to the aqueous hydrogen peroxide? The catalyst increases the activation energy for the reaction. A catalyst's job is to decrease the activation energy. The catalyst is used up during the reaction. No, the catalyst is regenerated at the end of the reaction. It might get used up, but it is regenerated. That means it is there when the reaction ends. The gas syringe fills up more quickly when the catalyst is added. Yes, it speeds up the rate of reaction, and the result of this reaction is production of oxygen gas. So the production of oxygen gas will take place at a higher rate. And the total amount of oxygen produced increases when the catalyst is added? No. A catalyst only speeds up the rate of reaction. It has no effect on the quantity of the products being produced. So this makes option C the correct option for this question. Question 20. Reduction can be defined in terms of gain or loss of oxygen or of hydrogen or of electrons. Which row correctly describes all three definitions of reduction? Okay. So reduction is loss of oxygen. So options A and B get eliminated. Options C and D remain. Reduction would be gain of hydrogen. So option C gets eliminated. Option D remains. And reduction would be gain of electrons, which is there in option D. Therefore, option D is the correct option for this question. And similarly, if the question had asked about oxidation, then we would have said gain of oxygen, loss of hydrogen, and loss of electrons. Both, in fact, all three of these are the definitions of oxidation.